Hey everyone, today we're going to discuss about descriptive statistics. Sa part ng lesson natin ngayon, we're gonna focus on how we're going to interpret data. And this is especially useful kapag nag-research na kayo next year. Kung mapapansin natin rin, yung sa part ng book natin, nag-end na siya kay correlation analysis, yung last lesson natin. Itong part na to, yung descriptive statistics, pati inferential statistics, these are just added content na I believe din naman na makakatulong sa inyo, especially next year na kapag nag-research na kayo. Kasi para ma-interpret nyo yung data ng research nyo, ang kakailanganin nyo itong mga topics ito, yung descriptive and inferential statistics. Okay? So it's important to study about this part. So when we talk about descriptive statistics, from the name itself, describe. They summarize a given set of data, which can be a sample or a population. Kapag meron kayo na-receive na data from your research and you want to describe that data, you describe it using descriptive statistics. So, ano ba yung mga ina-apply natin kay descriptive statistics? Isa sa mga yun ay yung frequency distribution. Ang frequency distribution, it is a tally or count of the number of times each score on a single variable occurs. So basically, table siya na kinakount mo lang yung frequency. Like, for example, itatali mo ilan yung mga grade 11, itatali mo ilan yung grade 12, itatali mo ilan din ang logical, ilan din ang visual. So, tally-tally, i-table mo lang. Ang tawag doon ay frequency distribution. Now, it's important na kapag nag-research tayo, alam natin yung level of measurement natin kasi nakadepende dito kung paano natin i-describe yung data natin. Now, there are actually 4 levels of measurement. The nominal, ordinal, interval, and ratio level of measurement. Kapag sinabi nating nominal data, it is focused on categories of data. So, mga categories like favorite color, favorite food, opinion, yes or no, or maybe in a particular situation, or preference na preferred school, preferred university, for instance, preferred brand of laptop, something like that. So, nominal data yun kapag puro categories, puro qualities ang kinukuha nating data. Pag ordinal naman ang data natin, we focus on ranking of scores na mayroong leveling na yung data at equally spaced sila. For example, socioeconomic status. Kung nasa poor, middle class, or rich, something like that. And actually, there are 7. Marami yun eh. Another example, kapag nag-rate tayo, for example, sa Grab ng driver, pwede mong i-rate ng 1 to 5 stars. Ranking yan. You can rank them. So, yun ang ordinal. Basta may kinalaman sa ranking. Like, top 10 songs in the Philippines. Top 10 songs in Spotify, for instance. Ordinal yan. Interval data naman, these are data that are equally spaced. Equally spaced para kay ordinal. Pero yung differences between the two data are meaningful. For example, ito yung grades nyo. 88, 89, 90, yun yung mga grades nyo. Equally spaced sila, and kapag tinutrack mo sila, may meaning naman yan. Ratio, classification siya ng interval data. Pero ang lowest niya ay 0. Kay interval kasi pwede hindi 0 ang lowest nyo. Kasi kunyari, yung grades nyo. Pwede namang, hindi naman 0 ang lowest nun. Nasa 65 or something like that. Pero si ratio, dapat 0 ang lowest. For example, test scores, 0 ang lowest. So, yun. Unlike sa interval, hindi 0. Like temperature, ang hindi naman 0 degrees Celsius ang lowest, di ba? Pwede bang bumaba. Pero kay ratio, 0 ang pinakamababa. Now, in most cases, si interval at ratio data, parehas lang kung paano siya interpret. Parehas lang yung mga statistical test na ginagamit natin. So, minsan collectively tinatawag silang scaled or continuous data. Pag sinabing scaled data, we're referring to both interval and ratio. Kapag sinabing continuous data, we're referring to both interval and ratio. Ang nominal naman, minsan ang tawag sa kanya is categorical. In most books, categorical din ang tawag sa kanya. Okay? And there's also a special kind of nominal data. Ang tawag dito ay dichotomous data. Si dichotomous data, nominal siya, pero dalawa lang ang level of measurement niya. Ito yung ginagamit na data kapag kunyari you're being asked of your opinion and you would respond with yes or no. For example, gender, male, female. If you're, something like that. In favor ka ba or against in a particular issue. Yun. So yun, dichotomous data yan. Okay. Now, there are two measures that we can have in descriptive statistics. That the two are the measure of central tendency and the measure of variability. The first one is the measure of central tendency. It attempts to summarize the scores in a single data. There are three measures of central tendency: the mean, median, and mode. Pag sinabi nating measure of central tendency in a particular data, a given set of data, um, you try to summarize yung data na yun. For example, yung grades nyo in a class. 40 kayo sa isang klase, di ba? Tapos isa-summarize nyo yun. Paano natin ma-summarize yun? Gagamit tayo ng measure of central tendency. Kasi di ba pag 40, ang dami nila, di ba? So, pag gusto mo isang number lang to summarize the scores of everyone, we use this. Si mean, ginagamit siya kapag scaled ang data natin. Si median naman, ginagamit siya kapag ordinary data natin. Pero pwede rin naman kapag scaled in some cases. Mode, ginagamit siya kapag nominal ang data natin. And remember, mean, median, and mode, we've discussed that back then in junior high. So, please review that kung paano kinocompute ang mean, median, and mode. Also, pwede naman siyang i-compute na mabilis na sa Excel. So, you research on how to compute for the mean, median, and mode on Excel. It's just one Google away. Madali lang naman hanapin yun. Now, for the measure of variability, we describe the dispersion of scores. Pag sinabi ng dispersion of scores, gano'n ka-spread out yung mga scores ng data. It's important to measure kasi yung dispersion of scores kasi doon natin nalalaman yung consistency ng isang data. How consistent ba na kapag in a particular sample, kapag may kinuha ba akong person doon, gaano kalapit yung score niya dun sa mean. Pag mas maliit ang measure of variability natin, mas mataas ang chances na lagi mas malapit. Mas consistent na ang nakukuha natin laging malapit dun sa mean. Kapag malaki ang measure of variability, mas malaking range na pwede natin makuhanan. Mas maliit ang chances na malapit yung makukuha natin score dun sa mean. Okay? So, ganun ang dispersion ng scores. It measures consistency. How consistent is that group in having a score that is close to the mean. So, meron three measures of variability. Yung range, standard deviation, and the interquartile range. Ang standard deviation, I believe familiar na kayo dito kasi lagi naman napag-aralan yung standard deviation. For the range, it's just simply the highest score minus the lowest score. Interquartile range, it's quartile 3 minus quartile 1. Ginagamit natin ang range as the simplest measure. For standard deviation, familiar na kayo dyan. Ito yung usual na ginagamit natin, especially for continuous data. Interquartile range, ginagamit natin to kapag meron tayong mga outliers. Yan. Kasi kinoconsider lang natin yung scores from quartile 3 hanggang quartile 1. We essentially remove outliers kasi kay standard deviation, apektado yung outliers. So pag marami tayong outliers, the tendency is that it would have a large value for the measure of variability. Yung standard deviation medyo malaki. Pero para maiwasan yun, we can also use the interquartile range. Now, it's also important to check yung distribution ng data natin. How spread out yung scores are. Remember, hindi naman laging normal ang distribution natin. Pwedeng mag-deviate. So, paano natin i-check yung deviation na yun? We have what we call the skewness and kurtosis. Si skewness is the distortion or asymmetry of data in a normal curve. So, kapag yung value ng skewness natin is between -1 and +1, the data is approximately normal. So, yung bulk ng score natin sa normal curve nasa gitna. Kapag less than -1 yan, papunta yung bulk dun sa right side kasi yung tail nandun sa left side. Ang tawag dun ay negatively skewed. Pero kapag yung skewness natin greater than 1, yung bulk papunta sa left, yung tail papunta kay right. Ang tawag dun ay positively skewed. So, pag negatively at positively skewed ka, hindi ka normally distributed. And it's important to check if the data is normally distributed because it allows us to perform some statistical tests which we will discuss later on. Kurtosis naman, it describes how the tails of the distribution differ from a normal distribution. So, sa kurtosis, siya nadidikta how thick are the tails are. So, kapag yung kurtosis nasa 3, nasa normal distributed siya. Kapag lumiliit yan or lumalaki, nag-change yung value ng tails yan. Pero in most cases naman, kurtosis do not affect the result of statistical analysis. Now, kurtosis of 3 indicate that the distribution is normally distributed. However, may maibang calculators na ang kurtosis nila na normally distributed ay 0. Ang tawag po natin doon ay excess kurtosis. Now, in Excel, I believe excess kurtosis yung nilalabas nilang data kapag ginamit mo yung command na yun eh. So, check nyo lagi na kung kurtosis ba or excess kurtosis yung binibigay na data. Sa Excel, alam ko excess kurtosis. So, i-check mo lagi yung 0. Now, ano yung dapat natin gamiting descriptive statistics in a given set of data? Diba kanina, meron tayong level of measurement, nominal, ordinal, interval, and ratio. And meron tayong measure of central tendency, measure of variability, skewness, kurtosis. So, ano yung mga dapat natin gamitin dito? Okay? Kasi, ang isa sa mga mahirap na bagay when it comes to describing data is alin yung gagamitin mo. Ano yung appropriate na gamitin mo. Kasi hindi ka lang pwedeng basta-basta, gusto kong gamitin yung mean. Wala lang, gusto ko lang. Hindi naman pwede yun. Gusto kong gamitin yung mode. Hindi pwede. May mga criteria tayong sinusunod. So, ano ba yung mga criteria na yun? So, we check the level of measurement. In this case, we focus on nominal, dichotomous, ordinal, and normal. Kasi yung normal, yun yung scaled or continuous data. So, kung interval or ratio ka man, pasok na dito yan. Ordinal yan. Nominal, kailangan i-separate yung description kay nominal and dichotomous, which later on. Yan. So, let's start with plots. Pag sabing plots, ito yung mga tables na pwede natin gamitin. Importante rin kapag na-describe ng data, gumamit ng table because it allows us to view the data in a good way. We can observe patterns through tables and charts na hindi natin nakita kapag nilist down lang natin. So, it's suggested na gumamit tayo ng table. So, I leave it up to you to search kung ano ba itong mga table na to. Basta hanapin nyo at alam natin kung kailan siya dapat gamitin. For nominal data, ang pwede mong gamitin ay frequency distribution at yung bar chart. For dichotomous data, ganun din, frequency distribution and bar chart. For ordinal, pwede mong gamitin ang frequency distribution, bar chart, and box and whiskers plot. Especially useful tong box and whiskers plot because kapag pinlot mo to, makikita mo na kagad yung interquartile range. So, meron ka na kagad yung measure of variability for that. You can also use naman histogram and frequency polygon, pero it's mas recommended yung tatlo. For normal or continuous data, it's recommended to use histogram, yung ginagawa natin na bar for normal curve, frequency polygon, and box and whisker plot. Pwede rin naman yung frequency distribution ng bar chart pero mas recommended yung last 3 kapag continuous ang data natin. Especially itong histogram kasi mas magandang ginagamit talaga to kapag nag-represent tayo ng data. May nakita kayo mga bar graph. Yun. Now, what's the appropriate measure of central tendency given this particular level of measurement? Kapag nominal, gagamit tayo ng mode. Kapag dichotomous ang data natin, gamit tayo ng mode. Okay lang gumamit ng median, pero yung value ng median natin equal kay mode. So, let's just stick to the mode. Mean, pwede rin naman. Kasi, pag kinuha mo yung mean ng responses ng yes or no, it would give us an idea on saan leaning yung scores. Which would give us an idea kung nasan yung gitna. Okay? Kay ordinal naman, it's preferred that we use median. Okay? Kasi, for example, yung ranking ng 3 at 5, yung gitna naman nun, hindi naman 4. Kasi yung differences between the two data do not matter eh. Like, example, meron tayong songs ng top 5. Yung isa top 3 at isa top 5. Kasi, kunyari kung nag-top 5 ako, tapos nag-top 3 ba ako, ang average ko ba is top 4? Hindi naman ganun nag-work ang ranking eh. So, dapat hindi ka gumagamit ng mean. Dapat naging median ka. Okay? Pwede naman gumamit ng mode if you wish. Pero yung mean, ginagamit yan kapag ranks. For example, socioeconomic status, mga ranking. Pero, okay, it gives us additional information. Ako personally, ang preference ko is we use both mean and median to interpret ordinal data because it gives us information. Pero priority, median dapat. Kay continuous data or normal data, we use the mean. Pwede rin naman median, pwede naman both, pero it's much preferred to use the mean. For the variability, so nominal data, hindi tayo gumagamit ng tatlong yan. Range, standard deviation, interquartile range. We don't use that. What we use instead kapag nominal ang data natin is we analyze it by percentage. For example, nagsagot ng favorite color, may nagsagot ng red, blue, green, yellow, orange. To determine the variability, i-check mo yung percentage na sumagot ng red, blue, green, yellow. Ano nga pipilanggit ko? Basta yung mga colors na yan. Then we can see the variability there na how spread out yung scores nila. Yun. Medyo mas tasky kung paano i-measure yung variability ng nominal eh. Kasi hindi siya clear. Ganun din kay dichotomous. Mas magandang actually hindi mahirap mo malaman yung variability niya kasi dalawa naman ang scores eh. At ang range niya laging 1 lang naman dahil dalawa lang naman ang responses mo. So, yan. Kay ordinal, ginagamit natin yung range. Pwede rin naman si standard deviation at interquartile range pero preferred itong si range kay ordinal. Kay nominal kay continuous or scale data, preferred yung standard deviation. Pwede rin namang si range pero mas magandang gamitin si standard deviation. It has more analysis that it can offer than yung range. Kasi pag range, susubtract mo lang eh. And it gives you the highest and lowest scores. Pero kay standard deviation, marami kang pwedeng interpret. Pwede mo pang interpret yan ng mas maigi pa gamit yung z-score kapag normally distributed siya. Interquartile range, magandang gamitin kapag maraming outliers. Now, for the skewness, we only use skewness for ordinal and continuous data. Huwag nyo nang gamitin yung skewness kapag nominal ang data nyo. It's not appropriate for that level of measurement. So, refer lang tayo sa table na to kung, for example, given kayo ng research nyo, gusto nyo siya i-describe. So, hindi nyo alam kung ano yung appropriate na test na gamitin nyo. So, tingin lang kayo dito. Ano yung tamang table na pwedeng gamitin? Ano yung measure of central tendency? At ano yung measure of variability na dapat gamitin? And ano yung distribution? Dapat bang gumamit ng distribution? Ayun. So, ang i-check nyo ano bang klaseng data ang meron ka. And saan ba siya mag-fit? Sample tayo. A teacher wants to describe the test scores of her students. She found out the data is normally distributed. So, anong measure of central tendency ang gagamitin niya? So, check muna natin ano yung score niya, ano yung data niya. Ang data niya ay test scores. And remember, ang test scores ay continuous. They are scaled data. So, kapag scaled ang data natin, ano yung appropriate na measure of central tendency? It is the mean. So, the appropriate measure of central tendency that you use is the mean. Next question, what's the measure of variability? So, tingin tayo sa table ulit. Continuous data, variability, pwedeng range, and standard deviation. Pero ang pinaka-appropriate na gamitin is standard deviation. Basta as a rule of thumb, between range and standard deviation, ang piliin nyo si standard deviation. Because it can offer more scores. Kasi pwedeng equal ang range in two sets, pero magkaiba ang standard deviation. Is it appropriate to measure the skewness? Yes, because the data is continuous. Ano yung pwedeng gamitin table or chart to describe this? Balik tayo sa taas. Kapag continuous, pwedeng histogram, pwedeng frequency polygon, pwedeng box and whiskers plot. So, yun. It's just a matter of selecting lang eh. Ano ba yung dapat nyong i-select na test, na interpretation na dapat yung gamitin in a particular data. And search nyo na kung paano siya i-graph, paano siya isusulat. Yun. Ang importante, alam nyo na yung dapat gamitin. Kasi yun yung usually mahirap kapag research eh. Hindi nyo alam yung yung first step nyo. Kasi pag alam nyo na yung first step nyo, pwede nyo na pag-aralan at magagawa nyo na. Ang mahirap na part kasi kung hindi nyo alam yung gagawin nyo. So, itong lesson natin na to, it gives you the first step on what you should do in a research. So, yan. Aralin yung mga examples dito, okay? So, descriptive statistics allow us to describe the data. The measure of central tendency tell us how we can summarize the data in a single value. And the measures of variability tell us how spread out the scores are. The skewness and kurtosis of the data can also help us to determine the distribution of the data. So, that's that for descriptive statistics. Yung next lesson natin, inferential statistics. Medyo mas maraming kailangang aralin doon. Okay, so hope you guys learned a lot today. Thank you guys for watching and see you guys in the next video.